Target microorganisms. This is the module on microbiological testing of foods, and this lecture covers target microorganisms for testing in foods and the food processing environment. This presentation aims to aid in the understanding of utility organism tests and how to utilize these test results, define indicator organisms and list common microbes used as indicators, and finally, to understand the implications of positive or negative results of direct pathogen testing. Determining the microorganisms to test for and what stage and process to test will vary for different products and processes. We'll talk more in depth about the different microbial targets and the impact of targeting different product stages. It is up to you as the processor to determine what and when you should be testing. There are many sources to reference for a small processor. These include FDA guidance documents, publications from trade or industry organizations, university extension resources, and many others. That being said, there are certain requirements that you will be held to either by your buyers or by regulatory agencies. Again, as a food manufacturer, it is up to you to determine what these requirements include for your product. For example, the Food Safety Modernization Act Preventive Controls for Human Food Rule does not require microbial testing in the regulatory language. However, as a processor, you or your supplier will be utilizing microbial testing as part of your supply chain preventive controls. You will also be utilizing microbial testing to verify your process preventive controls. In addition, if you are producing a product that requires a sanitation preventive control for environmental pathogens such as Listeria monocytogenes or Salmonella, many of these activities likely will also be part of your quality assurance program as they directly impact the quality of your product. Utility organism testing is typically part of a quality assurance program. These types of tests are routinely used for verification of cleaning and sanitation. Examples are aerobic plate counts, or APC, and yeast and mold counts. These tests do not look for a specific microorganism, but test for a broad range or class of microbes. The results give you a general picture of the microbial levels of the food or the food processing environment. The acceptable level for utility microorganism tests will again vary based on the product and process, but in general, high results can indicate a contamination issue. This could result in quality issues including reduced shelf life or incipient spoilage. While not directly detecting for the presence of a pathogen, high utility microorganism levels suggest conditions are favorable for microbial growth or survival, leading to an increased risk for pathogens to be present. Many quality assurance programs also include testing for one or more indicator organisms. Indicator organisms are non-pathogenic microorganisms, but these microorganisms are closely related to pathogens. They grow under very similar conditions to pathogens and have a similar reservoir or source as the pathogens. Therefore, a positive test result for an indicator organism may indicate the presence of a pathogen. Unfortunately, there is not a one-to-one relationship between detection of an indicator organism and a pathogen, meaning that a positive indicator test does not always mean a pathogen is present, and a negative indicator test does not mean a pathogen is absent. Indicator organism tests can be used for tracking trends in microbial loads, for verifying that a process control is working as intended, for determining if cleaning and sanitation is effective, and for investigations into product deficiencies. Common indicator organisms are listed on this slide. They're ordered from the most generic to the most specific. Enterobacteriaceae, commonly called EBAC or EB, is a family of bacteria that includes some relevant pathogens such as Shiga toxin-producing E. coli and Salmonella. Coliforms are a subset of Enterobacteriaceae, and fecal coliforms are a more specific type of coliforms. Within fecal coliforms, a more specific test would be for generic E. coli. When it comes to Listeria monocytogenes, the most common indicator used is Listeria species. As part of your hazard analysis, you will have identified microbial pathogens of concern for your product and process. You can then select an appropriate indicator based on the microbial hazard that was identified. One may also opt to directly test for the pathogen of concern in foods or the food processing environment. This may be a regulatory requirement or be a buyer requirement. If a pathogen test is positive, all product in the associated lot must be recalled. A positive test result will also initiate a root cause analysis to determine what led to the positive test result. We will talk about the limitations of microbial testing, but I will mention here that a negative test result does not necessarily mean that your product is free of the target pathogen. Ensuring that good manufacturing practices and your validated processes are followed are much better indicators that your product will be free of pathogens than final product testing. In summary, utility microorganism testing is used for routine product and environmental testing. Indicator microorganisms are used to determine if a pathogen might be present in food or the food processing environment. Direct pathogen tests are used to determine if a pathogen is present in food or the food processing environment.